Next set, questions 5 through 8. Instead of calculating the amount of money in the account after each year, write an expression for the amount of money using 10,000 in the repeated multiplication of the constant factor. Then rewrite each expression using exponents. So in year 0, the account balance is 10,000. In year 1, the account balance is 10,000 times 1.05, which is that constant factor. It kept getting multiplied, right? So that's 10,000 times 1.05 to the first power. Year 2, they have done for us as well. They did 10,000 times 1.05 times 1.05, which is the same thing as saying 10,000 times 1.05 to the second power. Next year, it's going to be 10,000 times 1.05 times 1.05 times 1.05, which can be rewritten as 10,000 times 1.05, and that is 1, 2, 3 times. Here, this would be 10,000 times 1.05 times 1.05 times 1.05. That's all from year 3, and then we multiply 1.05 again. So how many 1.05s do we have this time? 4 of them. So we would have an exponent of 4. Next time, we're going to have 10,000 times 1.05 times 1.05 times 1.05 times 1.05. This is all from the previous year. And this year we multiply by another 1.05, making that 1, 2, 3, 4, 5 of them. So 10,000 times 1.05 to the 5th power. If I had to take a guess, I'm thinking this is going to be 10,000 times 1.05, and my guess is to the 6th power. One, 2, 3, 4, 5. That's all from year 5. And this year we're going to multiply by another 1.05 to make it 6. Describe the relationship between the year number and the exponential expression. Talk about the year number. So year 1, the exponent was 1. Year 2, the exponent was 2. So the year number is equal to the power of 1.05. Number 7. Write the expression to represent the amount of money in the account at the end of year 8. At the end of year 8. So it is going to be 10,000 times 1.05 to the 8th power. The 10,000 was always the same. The 1.05 was always the same. The only thing that was increasing was that exponent. Let t equal the number of years. A. Express Regularity and repeated reasoning. Write an expression to represent the amount of money in the account after T years. So I'm going to guess that it's going to be 10,000, because that always came up, right? Times this 1.05, and T is my number of years, so it's going to be raised to the T power. Evaluate the expression T equals 6 to confirm that the expression is correct. So we're going to do 10,000 times 1.05 to the 6th power. Let's see what we get. 10,000 times 1.05 to the 6th power. I get $13,400.96. Look at that. Off by a penny. A penny. That's just because we didn't round along the way. Remember, as I was going through these, I was rounding as we went through. Here, I rounded in the very end, but it's only off by a penny. Let's take a look at year 10. 10,000 times 1.05 to the 10th power. They say it is $16,288.95. Again, only off by 1 cent. Only off by a cent. Take a moment to write down the information from 5 through 8, and then we'll move on to the next set of questions.